We are in Indonesia integrating renewable energy and aquaculture, and we are a stage 2 team. A little bit of summary, this is the ASU team, and this is the Venus team. Team description, we're a group of engineering students from many different disciplines, and our project is a renewable energy project. Our team is ASU 9 students, as well as 11 students from Venus University. So here's a couple pictures of our team meeting on Zoom with the Indonesia students. And our community partner is Venus University, and they're located in Jakarta, Indonesia. We collaborate with their faculty of engineering, including Dr. Hendarati, who is our main form of contact. Venus University has a lot of similar goals like ASU, committed to respect, innovation, teamwork, and empowering through community development, which is one thing that EPICS is so focused on. Along with this, we have met with individuals from Crustia, and they are a company that is doing kind of what we're aiming to work on. They are a higher end product, commercial use for farmers, and it implements all the things that our project is implementing, except ours would be a lot cheaper solution and would also be something that we would create on our own and then maybe give to them depending on what the needs are. History on our project. So we started in fall 2024, however, none of the members returned. They already had kind of a solution, but then we came along and we decided that we wanted to start and build something new that we could also call our own. So the problem statement is many small-scale fish farmers in Indonesia lack affordable and reliable aeration solutions, impacting fish growth and also farm productivity. So our project aims to design a cost-effective solar-powered aerator that will improve water quality and also support sustainable aquaculture. So there's 3 different components to our projects that we were allowed to work on. It's a pretty open-ended project. Floating photovoltaic device, which will power aerator, fish feeder, and sensors. GIS implementation by using either Google Earth or other ways to determine where these devices could be implemented and also used. And finally, IoT, which will share the data above to a website or app. So basically using those sensors and making some sort of smart component. So this is our current final solution. It is a CAD base and it includes a 2400 watt solar panel, frame, floats, aeration system, and it will use a paddle aeration system. The batteries and other components such as the motor are not shown on this prototype, but that would have to be further implemented in later. And these are kind of some of the images that the Indonesia students presented in a conference. This on here would show kind of what the app would look like that would connect to this device. So our team this summer also visited the shrimp farms, and these are some pictures that they took. They already used that paddle aerator that's shown in the bottom left corner, and they're implementing solar panels, but our device would have the solar panel on the system. So our long-term prototyping plan would be to purchase all required materials, wire it Raspberry Pi, wired circuit, build mechanical, build electrical, connect, test, and then continue. But this would be very expensive and would probably need additional funding based on how expensive the electronic components are. Semester plan for now, though, is to do a small-scale portable prototype that we can bring with us on our study abroad. So here's our current progress. We're currently 3D printing, wiring, and as of now, the project isn't finalized, but it will be in the next coming days before our study abroad, and we plan on testing this as well. So this is our budget. Currently, we're in December, which is to prepare for study abroad. Next semester, there'll be new members, and then as going on as needed for the team. And here's our current budget. There's a lot of wiggle room, but I also recommend if you want to use full electric, finding other ways to fund it as well.